this video, we are going to have a look at the list interface and its subclasses and see how it works and when we would prefer using subtypes of the list interface over other collection classes. First things first, a list allows you to store duplicate values. That is, in any of the subclasses implementing the list interface, the property is the same. We can store duplicate values. Besides, list subclasses like ArrayList and LinkedList are both ordered collections. The list interface provides you with positional access to the objects stored within, and hence you can add, get, replace, and delete elements from a list by the index. Without further ado, let's get our hands dirty and write some code here. And I've opened my IDE, that is Eclipse, for this video, and we already are in the main method, and let's start creating a list. So I'll just import it from java.util, and I'll say this list is of type string, and I'll just call it list of names. Assign it to the first list subclass that we are going to have a look at is ArrayList. All right, so this is a list of strings now, and let's call the method add on it, which takes a string now. And let me just copy paste it a few times. Let me just add a few names here. I'll say the name that is Steffi. I'll say Gargi. I'll say Omar. I'll say Sana, and I'll say Praveen. All right. Now, when we'll just print this list out, I'll say system.out.println, and I'll just say list of name. Let's call it names. Let me just correct this everywhere. Okay. So you'll see that we'll get the data stored in insertion order. That is how in the order in which we insert elements is the order in which they're going to be saved. That is, we'll get Steffi first, then Gargi, Umar, Sana, and Praveen. I'll say we run this, and that is what you're seeing. That is, you get Steffi, Gargi, Umar, Sana, and Praveen in the order in which we inserted them, because ArrayList, like arrays, maintains the insertion order. And as I told you, we can add duplicate values as well in any type of a list, be it ArrayList or a linked list. Let me just add Umar again, and I'll say duplicate value allowed, because it's a list and you should see Umar 2 times. See, that is what you're seeing. So it gives us data in insertion order, allows duplicate values to be stored, and because it's like any other collection, so you can grow the list dynamically as you're doing now, or you can shrink it. Let me give you an example of that. Let's see, I'll just print out here system.out.println list size is, there's a method that is size. Let's call that. So after adding 3, we should get the size as 3, and then I'll say after adding a few more objects, list size is. I'll say concatenate it with list of names dot size. Sorry, not the set method, but the size method. Right. Save and run this. See, the size is 3 initially, and then after adding a few more objects, list size becomes 6 because you have added 3 more objects into this list of names, which is a string only list. That is, it's growable completely. And now let's try to remove as well. I'll say list of names dot remove, and we have 2 overloaded versions of remove here. One, we can remove by index or by object, and here I'll just remove by the index first. I'll say remove the value at index 2, that is 0, 1, and 2. So one of the Umars should be deleted, and when you print the list, there should just be 1 Umar now, and that is what you see. There's just 1 Umar. And then you can even remove by object. I'll say remove, and I'll put in the string object to remove. I'll say Sana, and now you should not see Sana displayed here. You just see Steffi, Gargi, Praveen, and Umar on your screen, guys. Right, so it's growable, it is shrinkable. And now, rather than printing it like this in the crude way, why not to traverse it, right? And you can use it, you can do that in a few ways. I'll say values in list R. So we can do it through the traditional for loop or the enhanced for loop with Java 5 enhanced for loop with the iterator, or you can even do it with Java 8 for each. Let me just walk you through all of these. Let's first do it quickly through a traditional for loop. I'll say for int index set to 0, because again, indexes in a list start with 0, and I'll say list of names dot size. All right, I'll say index is less than list of names dot size, and then index increment like we always have been doing. And then I'll just say print ln list of names. There is the method that is get by index, prints the object at that particular index. Let's say we run this, we should get it on screen on different lines. Values in list are Steffi, Gargi, Praveen, and Umar. Insertion order again. So I'll just comment this now. I'll do it through an iterator. I'll say or traverse through an iterator. All right. So I'll define an iterator reference variable from java.util again. Let's put it of type string because the list we're traversing is of type string. I'll just call it the iterator. And let's get it from the list dot iterator. All right. And then using a while loop, we'll traverse it. I'll say while the iterator dot has next, which checks whether this iteration has more elements as the documentation is telling me. Returns a boolean, and then within the loop I'll say print ln, that is the iterator dot next, which returns the next element in the iteration. You're seeing that here. Okay, so until we have reached the end of the list, we should get every element listed on your screen. Again, values in list are Steffi, Gargi, Praveen, and Umar. For the end user, makes no difference whether the developer is using a traditional for loop or an iterator or even an enhanced for loop. Let me just do it through that. I'll say or through an enhanced for loop, which was introduced in Java 5. So makes it easier. That is, you write succinct code, less verbose code. I'll say string name from list of names and just print it out. As you're seeing, there's no condition, no checking for the has next, no checking for the index, and no increment or decrement. And you just print out the name. Better readable, enhanced, and intelligent. Same and run this, we should still see the same output. As I told you before, the end user is not going to find a difference. Steffi, Gargi, Praveen, and Umar listed down for the end user. And now it gets even better. It gets even exciting with Java 8 for each, or traverse through Java 8 for each. All right, let's do it. It's just one liner code now saying list of names dot for each. That's it. And then I'll say system dot out method reference print ln. Just one liner code. Are we kidding or what? This is absolutely wonderful. Save this, run this, you should see the same output. Steffi, Gargi, Praveen, and Umar listed down for you. And that is how the for each makes for incredibly succinct code. So that's about array list and how it allows duplicate values, how it stores elements in insertion order. Next is the linked list class. I'll just create a new class quickly for you. I'll just call it linked list demo in the same package that is com.walid.java.training. I'll hit finish. Let's quickly have the main method. All right. And this time again, I'll say list. And I'll do it with linked list. All right. From java.util. Let's say we want to store integers now. And let me just call it list of IDs. I'll assign it to linked list. and then use the method again, list of IDs dot add, as we had done in integers, sorry, in the ArrayList class. And I'll just copy paste this so that we have some data to play around with. Let's put in some IDs. All right. So again, you'll see this would be, and I'll be using the for each, Java 8 for each, the best we have yet for traversing these collections. Use the system.out method reference print ln. And you'll again see insertion order, that is 34, 21, 292, and 34 on your screen. And that is what you're seeing, right? Now, in addition to the add method found, which we use with ArrayList, we have the add first, add last, remove first, remove last, because now linked list gives you positional access. You can add or remove in between the list. You can add or remove at the top or the end of the list as well. So I can do that for you. I'll say list of IDs dot add first. Absolutely. You can add at the top of the linked list as well. I'll say 98. And you run this, you should see 98 at the first, right? Similarly, specific methods to the linked list class which are not found in ArrayList, and that is I can say dot remove first. So I can even say list of IDs dot add last. Absolutely. See, otherwise all the other methods like remove or get, they're the same as with ArrayList. And again, because linked list also implements from the list interface, it also allows duplicate values. See, I'll say list of IDs dot add, and we'll say 292. Although this is already present in the list, but allowed because of the fact that it's a list. You should see 292 twice. See. So the elements again in insertion order for you. So that is about list, and its subclass is ArrayList and linked list. And when would you prefer which subclass of the list interface depends upon your requirement and your preference as a developer. Generally, in terms of performance, ArrayList is better, but when you have a lot of insertions and deletions to do at the top, at the end, or in the between, you would prefer using linked list. For other scenarios, you'll go for using the ArrayList, which is again a subclass of list. So I hope you had a good understanding of how a list works and what are the subclasses of list, and in what scenario are you going to use which kind of a list, an ArrayList or a linked list. And then I'll see you in the next video.